welcome to another video on Vedic Maths Techniques. In this particular series of videos, we find out various tips and tricks to calculate things or calculate numbers. I guess you would have seen the first 11 videos. If not, please check them out first. In this particular video or in this particular chapter, which is chapter number 12, we will be discussing how to find out the last digit of a number. Well, if a number is given to you, its last digit is obvious. But what do you do in cases like the ones which are given here? What will be the last digit of 38 to the power 42 or 38 to the power of 179283842 and stuff? I believe that after spending 5 odd minutes on this video, you will be able to do all these calculations a lot faster. At least that's the hope. These videos are brought to you by an academy. This is our YouTube channel. Please subscribe to it. I'm Ravi Handa, and I run this website called handakafunda.com. Do check it out if you get the time. So, to figure this part out, to find out the last digit of a number, you first need to see what are the theoretical last digits possible. And that list is given here. From 0 to 9, anything is possible. Now, if you have a number which ends in 0 and you raise it to any power, it will always end in 0. So what I'm trying to say is, let's say if you have any power of 30, it will always end in 0, because when you do 30 into 30, what will happen? Last digit will be, you will get the last digit by 0 into 0, which will give you 0 again. Very similar logic, 1 into 1, any number of times you keep on multiplying 1 into 1, its last digit will remain 1. Are these the only two which follow this pattern? No, there are more. 5. You multiply 5 with 5, you get 25. So, any number of times you keep on multiplying 5 with 5 with 5, any number of times, it will always end in 5. And exactly the same thing is followed for 6 also. Any number of times you keep on multiplying a number which ends in 6, it will end in 6 only. So, just by looking at these ideas, we can say 35 to the power 72 will end in 5. No further calculations are required. 5 raised to any power. It does not matter whether it is 72 or 723. Whatever was the power, it would have ended in 5. Very similarly, for 51, it doesn't matter what is before 1. It doesn't matter what is the power. This will always end in 1. And my answer here would be 1. But what about the others? Do they follow some sort of a pattern? Yes. Let's check for, let's say we do for 4 and 9 first. There is a particular reason why I am picking 4 and 9, which I hope you'll understand. So what is 4 into 4? 4 into 4 is 16, or it ends in 6. Then if I have to do 4 into 4 into 4, and I need to find out the last digit of this thing. So what I can do is, instead of 4 into 4, I can use 6, and 6 into 4 will again give me 4. If I had 4 into 4 and I had done this 4 times, what would have happened? The first 3 times would have given me 4 again, and 4 into 4 would have given me 16 again or 6 again. So what I'm essentially trying to say is, when you keep on multiplying 4 with itself, you will either get a 4 or you will get a 6. If the number of times you are multiplying is even, say it was multiplying 2 times here or 4 times here, you will get a 6. If the number of times you are multiplying is odd, you will get a 4. Very similarly for 9 also. If the power is odd, you will get 9. If the power is even, you will get 1. That's it. Because 9 into 9 is 81. So the cycle, so to say, will be 91919191 and so on. So let's see what will happen here. The number ends in 4. Anything before that is not significant, because we need to find out the last digit. We only need to be bothered with what we have here is 4. And what is the power? 1249. I don't care what the power is. All I need to know is whether the power is odd or even. Since the power is odd, what will be my answer? 4 when raised to odd power will give me 4. So my answer will be 4. On the other hand, if the question was 74 to the power of 122, then the power would have been even, and then my answer would have been 6. but in this case my answer is 4. Very similarly for 79, the only thing that matters is 9 and an even power of 9. What do you do on an even power of 9? You write 1 as the answer. If this was 79 to the power of 1249 or an odd power, then your answer would have been 9. But in this case, the base is 9, power is even, your answer will be 1. Yes guys, it is that easy. You can just look at it and say what the answer is. But it becomes slightly more complicated when the ending digit is 2, 3, 7 or 8. Because here the cycles become longer. Let's first try and figure out what the cycles are. 2 to the power 1 ends in 2. 2 square is 4. So it ends in 4. 2 cube is 8. So it ends in 8. 2 to the power 4 is 16. So it ends in 6. 2 to the power 5 is 32. So it is back to 2 again. Which means the cycle for 2 is 2, 4, 8, 6. Let's do the same exercise with 3. 3 square is 9. 3 cube is 27. And 3 to the power 4 is 81. 3 to the power 5 is 243. So we are back to 3 again. And my cycle is 3971. Now there is another way that you could have obtained this cycle is if you just kept on multiplying 3 with the result. 3 into 3 is 9. 9 into 3 is 27. I just need the last digit. So 7. 7 into 3 is 21. I just need the last digit. So 1. 1 into 3 is 3 again. And the cycle repeats. Now in 3 it does not make that much of a difference, but in 7 it will. Let's see. 7 to the power 1 is 7. 7 square is 49. 7 cube. Most of us don't know what 7 cube is. And for those of you who do, it is 343. But you get 3. 7 to the power 4, now even you will stumble. So that is why I am saying that multiplying is a good idea. 7 into 7 is 49. I am just bothered with 9. 9 into 7 is 63. I am just bothered with 3. 3 into 7 is 21. And I get a 1 here. 1 into 7 is 7 again. So obtaining the cycle is a lot easier if you just multiply the result or just the last digit. Let's check with 8. What do I get with 8? 8 into 8 is 64. So 4. Now instead of doing 8 cube, I will do 4 into 8 is 32. So 2 into 8 is 16. So 6. 6 into 8 is 48. So I am back at 8 again. And the cycle for 8 comes out as 8426. So if your base is ending in 2, 3, 7 or 8, what you will need to do is figure out where does this lie. Now let me take an example. I have 38 to the power of 42. So first of all, that is the same as 8 to the power of 42. And now where will that be? 8 to the power 1 answer is 8. 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12, 13, 14, 15, 16 and you can keep on going and seeing where 42 comes. But a much easier way to figure that part out is you divide 42 by 4 and check what the remainder is. What is the remainder? 2. If the remainder is 2, then my answer will be the second value in the list, which is 4. And my answer here would be 4. So please remember guys, whenever you have a cycle, what you need to do is find out the remainder of the power from the cyclicity. Whatever you get as the remainder, that value will be the answer in the list. So if instead of 38 to the power of 42, it was 38 to the power of 43, then I would have got the third value in the list. My answer would have been 2. Now, in case some of you are wondering, what will you do if it leaves no remainder? Let's say it was 38 to the power of 44. Now, 44 when you divide by 4 leaves no remainder. In case of no remainder, it is the last value in the list, which in this case is 6. So, what will be our answer here? This is 38 to the power of 1792383 and a very long number. Now, what you need to note is that 4, when you are dividing by 4, you are just bothered with the last 2 digits. Anything else is of no significance. So that means this particular question can be reduced to 8 to the power of 42. We already know 42 when you divide by 4 gives you 2 as the remainder. 2 as the remainder, second value in the list, 4 is your answer. So actually these two questions might look different, but they are exactly the same question. They have exactly the same difficulty level. Now something for a little more complicated. First thing, 52 to the power of 2986 is the same question as 2 to the power of 29876. The previous part is of no significance. Next, I need to check the cycle of 2. Cycle of 2 is 4. That means there are 4 values in the list. If there are 4 values in the list, I know only the last 2 digits are important. So this becomes 2 to the power of 76. And then I apply the concept of power by cyclicity. If I do 76 by 4, what is my remainder? It is perfectly divisible. There is no remainder. And if there is no remainder, my answer becomes the last value in the list. What is the last value in the list here? The last value in the list here is 6, and hence my answer for the last question, which was 52 to the power of 29876, is indeed 6. So that is, guys, how you find out the last digit for a number. I hope you learned from it. Please don't forget to subscribe to our channel. Thank you.